Hello and welcome to watch this video. So this is a second video about some very basics about the world of computers. So last time we studied binary numbers and we studied how binary numbers are stored in the memory of computers. And this time we are going to study how computers store textual information. And that is then related to character coding, which means that there are certain standards how characters are stored in computer memories. One important standard is this Unicode, and another old standard is this ASCII or American Standard Code for Information Interchange. At the end of this video we will also study a little bit about how sound and how pictures and how moving pictures can be stored into computer memories. And well, my name is Kari Laitinen, and let's start studying them. So last time we studied already this that how you could think about a computer memory, and you can think that it is a very long list of 1 byte memory slots, and to each memory slot you can store one binary number in the range from 0 to 255. And when you are using several of these 1 byte memory slots, you can store then larger numbers. So, but then about storing text to computer memory. So there is this there are certain rules how text is stored. And it is very important to remember that computer memories can store only integers or whole numbers. So for that reason the computer industry has developed, or the computer companies, they have developed standards how to store text as numbers. And here when you go to this naturalprogramming.com site, and if you click this more icon here, you will find this codes icon here, and the codes icon brings you to this page, and there you have a list of characters, and then you have some numbers, both in decimal and hexadecimal form. And this table is then, well, you can say that this, or you can think that this is the old ASCII table. And so, for instance, if we start looking at this table, we will find that, for instance, the uppercase letter A here, it has this code 65 in decimal and 41 in hexadecimal. So that is the code of uppercase A, and then there is the code for uppercase B, uppercase C, uppercase D, and so on. So there are here codes for all the letters that are used in the English language. And then if you go here, you will find that there are codes for small letters or lowercase letters. So the code for lowercase letter A is 61 hexadecimal and 97 decimal. And the code for lowercase b is 62 hexadecimal and 98 decimal. And there are again codes for all the letters that are used, for instance, in the English language. And you will find also that there are codes for some special characters, for instance the $sign. It has code 24 in the hexadecimal system and 36 in the decimal system. And the code for the plus sign is then 2B in hexadecimal system and 43 in the decimal system. And you can note also that the space character has a code. But you can't see the space character, but it is the character that you can create with the space key of the physical keyboard. So that has code 20 in hexadecimal form in hexadecimal system and 32 in the decimal system. And you can note also that all the numbers or the digits, they have codes. 0 has the code 30 in hexadecimal system and 48 in the decimal system, and digit 9 has code 39 in hexadecimal system and 57 in decimal system. And all these, most of the special characters are also coded in this table of character codes. And in this first column of character codes you will find also some special character codes that are not visible to the human eye. For instance, they are not similarly visible to human eye, like the letters, for instance. And here you can find codes for instance, there is this CR, which is carriage return, and there is the code elif, it's line feed or new line. It means that, for instance, if there is text, there is also usually a new line character at the end of each line. And then the other codes here, they are usually used in some telecommunications protocols, for instance. So this is the basic idea that for instance, if somebody stores some character, or for instance, if in an email you are sending a message that contains the letter N. In practice, it is so that the computers will send the code 4E in hexadecimal system, and when the sender and the receiver know that this 4E means the uppercase letter N, then it is possible to communicate. For instance, just to make these things clearer, we could take some text and see how it would be stored in the computer memory. So that, for instance, if I would, I'm going to be selfish here, so I will take my own name. So my name is Kari. So it has a uppercase letter K, lowercase a, lowercase r, lowercase I. So the code for the uppercase K is then, I will use the hexadecimal numbers here, so it is 4B, and the lowercase a is 61, and then the lowercase r is 72, and the lowercase I is 69, like this. So if this then would be stored into the computer memory, So and when we remember that computers always store numbers in binary form, so we would have to convert these numbers to binary form. And well, I can try to use this because we took a look at these numbers last time. But I will do this conversion here. I don't explain it. But for B, it is in binary form. It is something like 4B. So let's think that these numbers, they will or these codes will be stored into these 4 memory locations. So this 4B is then, if we store it there, it would be 0, 1, 0, 0, and B is then, I get it from there, it is 1, 0, 1, 1. 1, 0, 1, 1. So this is 4B, and 6, 1 is then, this is 6. 6, 1 is then, so this is 6, and 1 is in hexadecimal, and it's the same as in binary, so it would be like this. And 7, 2 is then 0, 1, 1, 1. This is 7, and 2 is like this, and 6, 9 would be then, so this is 6, and 9 would be then 1, 0, 0, 1. So storing my name in the computer memory, it would contain these binary numbers there, and well, the computers can understand the binary system, so they could handle that. And in practice, as we spoke last time, these binary numbers would be stored as electronic voltages or electronic currents. And in logical way, we can think that the computer stores these binary numbers. So this is the basic numbering system, and so you can think that these codes that are shown here, they are the classic ASCII codes. So we spoke about these ASCII codes, American Standard Code for Information Interchange, and the newer coding system is then this Unicode system. And what in practice it is that this Unicode system, it is just a kind of extension to the old classic ASCII coding system. And well, I have here a link so you can find this table through this naturalprogramming.com, and I have here a link, more character codes. So there is a Unicode character codes, and so there is this first. If I click this, I get to the pages of the Unicode organization, and for instance, I can find here that, for instance, that the code for uppercase A is 0041, and the code for uppercase B is 0042. So they are basically the same codes as the classic ASCII codes, but they have two preceding zeros. So basically these Unicodes, they are then at least they occupy at least 2 bytes of memory, and there can be more of these codes. So it is with this Unicode system, it is possible to store many more, or it is with this Unicode system, it is possible to describe many more characters than with a classic ASCII coding system. So for instance, if you go to these pages, or if you check these pages, you will find that there are codes for arrows and there are codes for mathematical operators. So for instance, if we take a look at this page here, we will find that the code for this, I think this might be the union sign or something like that. I have forgotten many things about mathematics, but this this kind of code, it has this or this kind of symbol, it has this numerical code 22C2 in hexadecimal system. And this, I think this is sigma or something like this, so that has code 2211 in the Unicode hexadecimal system. So with the Unicode is basically an extension to the ASCII system, and with that Unicode system you can really code many more characters than not just the English letters. So if you want to study these more, you can find through this link you will find all Unicode character code charts. But we are not going to study them now. So the basic thing here is that you understand that all the characters of text are coded in the world of computers. They are coded with some numbers, and it is very important that the programs or the communicating computers, they know how the coding works. And these are usually the most important codes that are shown in this table here. So we could still study this a little bit more, so that I can show also in practice that how this character coding works. Because I'm now using a iMac computer here, and in this iMac is based, or this computer is based on the Unix operating system. So there is the Unix operating system here running down there below this graphical user interface. But it is possible also that I can go there and use the Unix system. So I have here now a file here. So if we take a look at this file system, I have a file here in my user account. I have this documents folder, and then below that I have this MISC folder, and I have this testfile.txt file there. So, and I have that file actually open here in this editor. And that file, again, it contains my name, the 4 letters there, and nothing else. And I have stored it there. So now there are some special Unix tools that I can use to go and check that what is really contained in that file in numerical form. So I will use this terminal window that is in Mac computers. So I will use this terminal window, and I will go now there to the to that folder where this file is located. So I use first the cd documents command. I change the directory. Folders are also called directories, so I change to that directory, and from inside that directory I change to misc directory, and there I can list the files. So I have one GIF file there, and I have I have the test file .txt there. So now there in Unix there is this tool called Hex Dump, and that shows the file content of the file as hexadecimal form. So I can see the file this way, and it shows the numbers inside the file. So there is 4B, 61, 72, 69, and they are, I think they are now exactly those codes that I got when I hand converted this my name to hexadecimal character codes. So they are there. You can see, and there is also this 0A. You see that there is also this number 0A there, and if we take a look at these character codes, so it is 0A, so it is this line feed or new line character that terminates the line there. So now these numbers, they are stored into a file, but so it is so that also the computers work so that when they store text, they also inside files the text is encoded with these numerical codes. And if I modify this, the text in this file, for instance, I can, let's put the hello and exclamation mark, and I save it, file and save, and then I go into this window and I redo this hex dump test file.txt command. You can see that now the codes are different, and if we take a look, we see that there is 48, which is the code of uppercase H, and there is the 65, it's the code of lowercase e, and there is 6c, it's lowercase l, and twice that code, and then this must be the 6f is the code of lowercase o, and also this 21 is the code for the exclamation mark, and again there is this new line code at the end of this text. So here you see in practice that really these the correct coding happens in practice, and there I had to use this special program Hex Dump to see the character codes, but I can also use this, for instance, if I use this more command and give the file name, so there I see it as characters. So it is important to note that here this more command can then understand the character codes, but this doesn't care about character codes. So I think this is now enough about the character coding and textual information. So we could take a quick look then at other types of information. So I did show you this slide at the beginning. So computers can store sound, they can store pictures, and they can store moving pictures. And the principle is basically the same, that all the sound is converted to numbers, pictures are converted to numbers, and moving pictures are converted to numbers. And there are standards how these conversions happen, and they are very complicated, and I just can't explain them very quickly here, or profoundly here. And so they are very complicated ways how sound and pictures and moving pictures are encoded. But you have certainly seen these file types. So you have seen that there are WAV files, there are MP3 files. So these files then they contain music in numerical form, and for instance these JPG and PNG files, they contain pictures in numerical form, and these files MOV and MP4, they contain moving pictures in numerical form. Of course, this MOV file and MP4 file, they also contain sound. So, but the basic idea is also so that with these files, the computers, so that when for instance a moving picture or the picture is stored as a PNG file, it is essential that the computer or the computer application can understand this how this picture information is encoded. I had here another file. If we take a look, ls is the command. So I have this file curry icon rounded, which is this my face that can be found at naturalprogramming.com. But for instance, if we go, well, if I use this finder to show, so that for instance this finder tool of Mac, it can show this GIF image as an image. But also this file, then it contains just numbers in binary form, and we can test it. So I can for instance, we will see here that this file, it has more than 11,000 bytes, so it's quite long compared to the other file there, but still it is just numbers there. And I can do also this Hex Dump thing for this GIF file, and you will see that it is just numbers there, a lot of numbers. But we can't because now these numbers mean that this image is now stored in the GIF or GIF format. So, but I think we have now covered the very basics of how information is encoded in the world of computers. So, numerical whole numbers are easily stored, but for other types of information like textual information, we have to use some standards like the Unicode or the older ASCII standard, and for other types of information we have these certain standards that produce certain types of files. But considering the future lessons about this series of videos, the most important thing is that we can understand this textual information and we can understand this numerical information, and we understand that computers store only whole numbers, which are also called integers. So I thank you for your attention, and I hope that we'll meet in the next video.